Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Thermal Toast 97. Thanks for the suggestion, Thermal Toast. You asked, how do heat-seeking missiles find their target? If you've ever watched an action movie where a missile locks on and chases a jet like it owes it money, you've probably wondered, how does that actually work? Can missiles really see heat? And how do they know what to follow without getting distracted by, say, the sun or a really spicy barbecue? Today, we're breaking down the red-hot science behind these flying firecrackers, right here on Explaining Everything. So, first off, heat-seeking missiles don't see like we do. They don't have little eyeballs with sunglasses on. Instead, they rely on infrared sensors, which detect infrared radiation, or in simple terms, heat waves. Everything warmer than absolute zero, that's negative 273.15 degrees Celsius, if you're wondering, gives off some infrared radiation. But the hotter something is, the more infrared it emits. Fighter jet engines, glowing hot. Humans, warm. Freshly microwaved burrito, also warm, though slightly less strategic. These missiles are designed to hone in on the biggest, baddest heat source in the area. And it turns out, the back of a jet engine is like a glowing neon "shoot me" sign in infrared. It's not magic, it's physics. Spicy, spicy physics. At the front of the missile is a part called the seeker head. Sounds like a Harry Potter house nobody asked for, but this is the real MVP. Inside the seeker head is an infrared detector, usually some form of cooled crystal, like indium antimonide. Why cooled? Because the detector itself has to be kept colder than the thing it's trying to find. Or else it would just pick up its own heat and get very confused. Imagine trying to hear someone whisper while you're blasting heavy metal directly into your own ears. The seeker head rotates or scans the sky to pick up heat signatures. Once it spots something hot, like a jet engine, it locks on and starts tracking. This is where the missile becomes a very determined dog chasing a very fast mailman. Now that the missile's got a target, how does it stay on course? Welcome to proportional navigation, a fancy way of saying, I'm going to cut across your path so I can smack into you. The missile constantly adjusts its flight path based on the angle between itself and the target. If the angle isn't changing, the missile's on the right track. If the angle is changing, it corrects its direction. Over and over. Rapidly. It's kind of like that one clingy ex who keeps showing up wherever you are. Except this time, it's a piece of flying metal with fire coming out the back. Guidance fins on the missile help it steer like a tiny plane, adjusting for movement, wind, and the fact that its target is probably not thrilled to be followed. Of course, planes don't just sit there like, cool, a missile. I guess this is it. No, they fight back with flares. Flares are bright, super hot chunks of burning material ejected behind the plane. The idea is that the missile gets distracted, ooh, hot thing, and chases the flare instead of the jet. Think of it as a game of throw the dog a fake stick and run the other way. More advanced heat seekers, however, have gotten smarter. Some can distinguish between the consistent heat of an engine and the quick burn of a flare. So the missile's not just chasing any old warmth. It's reading patterns, consistency, and intensity. Basically, it's trying to avoid being catfished by fireworks. The earliest heat-seeking missiles, like the M9B Sidewinder from the 1950s, could only chase targets from behind. They were like, "Show me that engine, or I'm not coming." But modern missiles? Oh, they've leveled up. Now they can detect heat from different angles, even from the front or sides, and they have imaging infrared, IIR systems that can literally form a picture of the target's heat signature. That means they don't just lock onto hot blob. They lock onto a specific hot blob with a recognizable shape. It's like facial recognition, but for flaming aircraft. So if the target tries to flare, dive, spin, or just scream in jet language, the missile stays locked in like a spicy bloodhound that skipped dinner. So, to recap, they use infrared sensors to spot hot objects, a seeker head to track them, and guidance systems to relentlessly steer toward their target. They don't get tired, they don't get distracted, and they definitely don't stop for coffee. Unless you're flying a jet, this probably won't affect your commute. But it's still one of the coolest and hottest examples of physics and engineering working together in terrifying harmony. If you learned something new about those stalking sticks of boom, don't forget to like, subscribe, and know they won't target a fart heat. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.